What we're going to do now is try to determine if two statements are equivalent. So thinking about that word, it kind of looks like it deals with equal, but it's not quite the same. And that's kind of the idea that we're going to have with statements being equivalent. So it doesn't mean that they're identical to each other, because there's no way a conditional statement and something involving and is going to be exactly the same, but they might still have the same underlying meaning, or in this case, truth value. So we say two statements are equivalent, which is symbolized by one of two things. You can do a double-sided equal sign, or a double-sided arrow equal sign, or you can use a triple equal sign. Okay. So the way two statements are equivalent is if they both have the exact same truth values in that final column of the truth table, because that's the truth value of the statement overall. The thing you have to be careful with is you need that same starting order for the statements P and Q. And if there's three, P, Q, and R, you have to have the same combination of truth values to begin with. So we're going to try an example. We're going to look at the conditional statement, if P, then Q. And then we're going to look at the statement, not P or Q. And we want to see, are these equal to each other? So I'm going to show you two different ways you can go about it. The first way is you're going to create a truth table for each one. And in this case, you need, again, the same starting values. Nope, that should be true. Okay. So this is the same setup I've used every single time. I want to make sure I keep the same combination in the same order. I don't want to do something different, because I'm looking for those same starting values to result in the same truth value for that statement. So this better be exactly the same as these values here. Okay, they must be in the same order. Okay. Now for the first one, I can just go ahead and do that conditional statement. So again, I'm going to put in the corner just all the values. The first value for P is true. The second value for Q is true. And overall, this is a good statement. Remember, keep that conditional phrase. If you get an A, then I get you a car in the back of your mind. You got an A, I got you a car. I didn't break my promise, so I was truthful. I did not lie to you. In this second case, P is true and Q is false. So you got an A, but I failed to get you a car. I lied to you, so I made a false statement. In the third situation, P is false and Q is true. You did not get an A, so no matter what, I'm not going to break my promise because you didn't uphold your end of the bargain. So this leads to a true statement. And finally, for this last one, P is false, Q is false. And again, you didn't get an A, so I will not break my promise to you because you didn't meet that starting criteria. So these are the truth values for this first statement. Now I want to see what are the truth values of this in the end. So before I can do this or, I need to figure out what are the values of not P. As soon as I have those values, I have not P's values, I have Q's values, I can go ahead and figure out this or statement. So again, this means or. So starting with the negation of P, all it's going to do is flip these values. So it's now false, false, true, true. Okay. I need to do this or statement, so I'm going to start by putting not P's values in the corner. Those are false, false, true, true. We're doing the or operation. and then writing Q's values. Those alternate true, false, true, false. Okay. When I'm working with or, I'm asking is one or the other true? So as long as there is one T, I'm good. There's a T here, so this is true. There is no T here, so this is false. There are at least one T's here, and then likewise, there is a T here, so this is true. So comparing the final truth values of the statement, wrong tool, we've got true, false, true, true, and for those same initial combinations of truth values for P and Q, we've got true, false, true, true. So here, since these final columns match, we can say the two statements are equivalent. So what I can write is I have the statement, if P, then Q. You can use a triple equal sign and then write the other statement, not P or Q. One thing that's just a common practice is we'll put parentheses around each statement so it's a little bit cleaner to look at. Or again, if you don't want to use the triple equal sign, you can use that equal sign with a double-sided arrow. Either one is fine. Okay. So I'm going to do another one of these, and I'm going to show you a different approach to how to create the truth table, because you're really copying and pasting the same first two columns. Kind of tedious to write. So another way would be to really just create one giant truth table. So we're going to do the same thing. We've got the conditional statement, if P, then Q. And then we've got this statement, P and not Q. So let's create our truth table. So I've got my starting values for P and Q, both true, one false, false and true, and then both being false. I'm going to start by filling in however many columns I need for the first statement, but thankfully this just involves P and Q. So I can go ahead and do that conditional statement. Okay. So these are one of the sets of truth values I'm comparing. You don't need to do this, but I think it helps. I like to put a blackout column. So this way I know, okay, this is the end result for one statement. And then the very end result over here is the other one I'm going to compare it to. So it just makes that separation pretty straightforward of where the one truth table ended. Now in these columns, I'm going to go ahead and put all of the headers I need to figure out this second statement. And again, it just makes it nice because I have the same starting values now for each of these end columns. So in order to do P and not Q, I need the values of not Q. Once I have those, I've got the values of P, I've got the values of not Q, I can then do this end. Okay. Now I'm going to fill in these truth tables, and again, I'm comparing what are these truth values and these truth values. So starting with the first one, I'm going to go ahead in the corner, put the values for P. So true, true, false, false. We're doing that conditional statement. And then Q's values are true, false, true, false. Okay. So I'm looking for that bad case where you get an A, but I don't get you a car. This is the only time I start out true and lead to false. So this case is false, but all of the others are true and no issues with them. So these are the final values for the first statement. Now I need to move on to the second, so I got to start by figuring out not Q. And again, in the corner, just to make things easy for yourself, I'm going to put the original values of Q, which are true, false, true, false. So not Q will be false, true, false, true. Okay. Now I need to figure out these truth values. So I'm going to start by putting P in the corner, which is true, true, false, false. The operation we're doing is AND. And then copying these values for not Q. This is false, true, false, true. For AND, it's asking, is this one AND, this one true? So they both need T's for AND to be true. This does not both have T's, so it's false. This one does, so it's true. Not both T's, not both T's, so those final values are false. So if I compare these two, I don't have the same truth values in the end. So since these columns are not the same, these are not equivalent. So you could use that triple equal sign with a slash through it. It's a little weird to do the double-sided arrow equal sign with a slash. So really just writing the statement they're not equivalent is fine. Okay. So what we want to get to now is we learned about that conditional statement. There's really a couple different ways or variations that we can write this. And we're going to ultimately see which of them are equivalent. So what I'm going to do is I'm going to give you the name of that variation, the symbolic form, and then how it's read. So starting out, we just have the conditional statement. This is what we're starting with. And that's if P happens, then Q needs to happen. So this is read if P, then Q. The first variation is called the converse. And what this does is it switches the order. So it starts with Q and leads to P. So this is read if Q, then P. Okay. After that, we have the inverse. And what this does is it keeps the original placement, but it negates them. So it's not P and not Q. So this is read if not P, then not Q. And then finally, the last one is the contrapositive. This one flips the inverse, or really what it does is it flips the original statement and also negates it. So you flip it to Q and P, and then you negate both of them. So this is read if not Q, then not P. Okay. The way I like to remember these are those variations that involve con at the beginning, flip the order. Okay. Contrapositive being the longest word does both of those operations. And then inverse changes the sign. The way you can think of that is like when you have an additive inverse, 1 plus -1 will make it cancel out. So what we want to do is figure out, do any of these result in the same truth values? And if so, which ones? So we're going to make a giant truth table with all 4 variations, and we're going to see which ones give me the same results. So to start out, I've got to put those values for P and Q, the same 4 starting values. Now, if I do not P, I'm going to go ahead and negate these 4 values. So that changes it to false, false, true, true. not Q switches these. So this alternates false, true, false, true. Starting with our conditional statement, if P, then Q. I'm going to start by putting P's values in the corner. So true, true, false, false. Again, all of these will have the conditional as the operation. And then Q's values are true, false, true, false. And I'm searching for that problematic case, which is right here. You got an A, but I didn't get you a car. So this one is false, but all of the others are true. Now I'm going to go ahead and do the converse, which just flips that order. So you can kind of cheat a little bit. You're just going to flip the sign here. So I don't need to go back and search all the way here. You can, but really Q's values go true, false, true, false. We're doing the conditional statement. And then again, I'm just picking these values right here because it's the reverse order. True, true, false, false. Searching for that bad case, it's going to occur in the third spot. You got an A, but I did not get you a car. So this results in a false statement, but all of the others are true. Next up, we'll do the inverse. So that keeps the order of P and Q, but negates them. So I really am going to be using these two rows for the inverse. Starting with not P, that's false, false, true, true. We've got our conditional, and then not Q is false, true, false, true. Searching for the bad case, that's going to occur right here, true to false. So this one is false, but all of the others are good. So right away, you can now see these two are going to be the same values. So the converse and inverse result in the same truth value. These are going to be equivalent statements. So if I look at my last one, the contrapositive, it's likely going to match up to the original statement. Con tells me to switch it, and then contrapositive being the longest tells me to also negate it. So again, it's just flipping the orders from the previous column, but really you're just putting the arrows in this direction. So not Q's values are false, true, and then not P's values are false, false, true, true. Searching for that bad case, it's right here in the second spot. So this one is false, but the remaining are true. So the conditional and the contrapositive result in the same truth values. Okay. So what I can say is that the conditional, if P, then Q, is equivalent to the contrapositive. So flipping and negating. You got to do both operations. Okay. So the conditional and contrapositive are equivalent. And then likewise, if I have the phrase, if Q, then P, the one it's equivalent to is flipping the order and negating them. So the converse is equivalent to the inverse. So we're going to do an example where we actually have a conditional statement and we're going to write the variations in sentence form. And I think that'll also help really solidify that these statements are equivalent to each other. So the phrase we're going to use is, if it snows in Florida, then school is canceled. So we're given the conditional statement to start with. This is going to be, if P occurs, then Q occurs. Okay. So P is going to represent the phrase, it snows in Florida. Q is going to represent the phrase, school is canceled. So I'm going to find the converse, inverse, and contrapositive of this statement. Starting with the converse. So con tells me to flip. So if Q, then P. Okay. So if Q is if school is canceled, then P happens, so then it snows in Florida. Okay. So this first statement makes sense. If it's snowing in Florida, we're definitely canceling it here because it doesn't snow. So school is going to be done, even for like a little bit of a flurry. When I go and look at the converse, you can see this is not really saying the same thing. Okay, well, if school's canceled, then it snows in Florida. That's not true. If school's canceled, then it could be a hurricane. It could be just like a holiday, something of that nature. It doesn't force this to occur. So these really don't have that same meaning. If I look at the inverse, which is equivalent to the converse, that's going to go ahead and negate my two values. So when I negate, all that's going to do is add the phrase not to it. So if not P, if it does not snow in Florida, then school is not canceled. And that also, you can see, has the same meaning as the converse. Well, if it does not snow in Florida, then school is not canceled. That's not true because, again, if it's not snowing, it could be a hurricane, so school would be canceled. Looking at that last statement, that contrapositive, this flips the original and also negates it. So also the way you can think of it is we're going to flip these. So this is, if school is not canceled, then it is not snowing in Florida, or it does not snow in Florida. And you can see that has the same meaning as the original sentence. Well, if it's not canceled, it's definitely not snowing, because if it was, it would be canceled. So it has that same underlying meaning as the original conditional statement.